Hello and welcome. This brief presentation will take a look at some new concepts in robotics, particularly as it applies to distribution. Robotics in general have come a long way in the last 50 years in regard to end-of-arm tooling, speed, and vision systems. As you can see, the robot on the right is a Motoman dual-armed robot. Vision systems continue to get better and more cost-effective, which really allows you fine control on your end-of-arm tooling as you're picking and placing devices. This is a typical palletizing cell that you would see in most distribution centers or manufacturing facilities where you are palletizing various types of products. In this example, it's various bags of products. In-feed conveyors and a slip sheet tier stand are used in conjunction with your outbound discharge conveyors, and the area is completely surrounded by safety fencing to protect your operators. This is a video showing each bottle picking. Here we have mounted a small robot on an ASRS crane. This is more often utilized in a restaurant application, but you can see the end-of-arm tooling uses an expanding bladder that goes around the bottle top in 2 locations and then places the bottle into a pickup and deposit stand for, in this case, a bartender. The robot has been integrated with the specific iPad menuing system to bring a bottle of wine to a patron. As you apply a little bit of this same technology into the distribution center environment, we have 2 vertical lift modules, which, in this example, store trays of bottles and then brings out a shelf of those bottles for a robot to pick. This is each picking or piece picking for bottles. As you zoom in, you can see a robot on a gantry rail over a takeaway conveyor. Shipping cases are erected and slugged into the pick area, and then the robot picks up the individual bottles and places them in the outbound shipping cases. In this particular case, we're using a single bottle pickup head. We'll show you multiple heads for a little higher velocity picking in just a minute. Now, as previously mentioned, we have 4 bottle pickup heads on this end-of-arm tool, and it's picking up 4 unique SKUs or bottles and then doing a batch put to 4 to 6 outbound shipping cases. This solution is very high speed, in the order of 300 line items per hour, about 50% faster than a human operator. This system was recently developed for supply chain of the future. Using bladder methodology, we picked up water bottles, then put them in an outbound case. Another concept we use for bottle picking is inverting a robot onto an AGV, which looks very much like a fork truck or order picker. We'll bring in a batch of inbound totes or shipping cases onto the AGV. Then, we in effect do aisle picking. We go up and down the aisle with the end-of-arm tool, picking bottles. We'll pick a specific bottle and put it into a corresponding tote for that particular order. And we have vertical elevation capability. This allows us to move up to higher levels in the racking structure as we go down the aisle and pick the orders. Here the AGV does a serpentine pattern through the aisles, stopping at the locations required, whether they are high or low, to pick the appropriate bottles. Once picking is complete in an aisle, the AGV will go around and do a circular pattern or serpentine pattern throughout the racking to pick all the appropriate bottles for that batch of outbound orders. Once the batch is completed, we go to the discharge conveyors where the totes are released, thus ending the cycle. Finally, you go pick up empty totes or shipping cases and repeat the process. This is a more detailed design for the racking structure, which is actually a hexagon-shaped structure, almost like a beehive, to support all the wine bottles. This application was designed for HEB, a grocer in Texas. It begins with full layer picking at the beginning of the system. thus allowing the capability to pick a pallet of full layers or create what we call starter pallets that may or may not have full layers, depending on the specifics of that particular order. Here we induct 4 starter pallets onto a robotic ASRS system. On top of the ASRS carriage are 2 gantry robots that independently travel down the aisle approximately 40 feet or 13 meters. The robots pick from the donor pallets and place cases on one of the 4 put pallets or build pallets. Each of these pallets on the ASRS carriage have a stretch wrapper, enabling you to stretch wrap the mixed pallet loads as they are being built, thereby adding stability as the ASRS crane moves. Basically, the crane moves from one pick zone location to the next. The advantage of this design is the ability to pick directly from a donor pallet to a mixed build pallet, eliminating unnecessary steps such as breaking down the donor pallets into individual cases and then attempting to recombine those cases again. The crane, having completed a specific pick zone, will move to the next pick zone. In this single aisle system, the cycle time was about 15 minutes to produce 4 mixed pallets. Of course, with this type of system, the software to build a 3D model is very important because your individual cases will be of different dimensions. It's also extremely important that your end-of-arm tooling has both vacuum and underside gripping capability to pick up a wide variety of SKUs. This is an example of a pallet flow tunnel concept. Basically, we're using automated storage and retrieval cranes on the outside and robotic picking tunnels on the inside. So your reserve inventory is above and to the right and left of the pick tunnel. The ASRS cranes feed the full or donor pallets down the pallet flow lanes to each of the 3 vertical levels. Then you have pick robots on gantries that are positioned above the takeaway conveyor to do picking directly from the full pallets. The full cases are then sent outbound on the conveyors after the picking takes place. Here we are using a robot for layer creation during a pallet build operation. You can see the robot taking a look at each of the individual cases coming in and then positioning them laterally and rotationally to place them in the right location to build that particular pallet layer. It's a popular technique, very accurate and very reliable. This is an example of a mobile robot that's picking up half layers. The donor pallets are on the right and left, and the robot takes these SKUs to build pallets of mixed SKUs. Then, the entire picking carriage moves down the lane. This was produced by Power Automation Systems, and the project was completed in Spain. Another mixed pallet building concept uses a standard order picker and 2 side-by-side pallets. Then, rather than a human being building the mixed pallets, a mounted robot picks from the donor pallet and places cases into the mixed pallet. This can be done for standard cases, pails of liquids, or bags. In these renderings, we see the same application with a robotic order picker, in this case being used for pails of paint. This is another example of a technique that combines robotic palletizing with automated case flow for higher throughput and more pick face or SKU availability. Automated case flow systems like this one for Pepsi are becoming more and more popular for building mixed pallets. The pallets are broken into individual cases and are stored in multi-level powered carton flow lanes. Then the cases are released in the mixed pallet build sequence, and the product flows in that sequence to the robotic palletizer, where they are palletized and shipped out. For each picking, often we'll leverage off of the tunnel pick concept. Again, we have two mini load cranes on the outside feeding cases into carton flow, with the pick operators in the middle tunnel. Using this concept, rather than the operators in the middle tunnel, we use robotics. As before, you can see the cranes to the left and right of the pick module. Again, we have a 3 vertical level system with case flow lanes that bring the cases toward the tunnel pick area where the robots are located. The robots are again on a gantry that is positioned above the conveyor, so they can pick the individual or piece products and put them into the appropriate shipping cases. Then the shipping case is ultimately discharged out of the robotic pick module to a palletizing area. Another picking technique with robotics uses horizontal carousels. Robots are positioned in specific zones between the carousels. This application was designed for Rexam using horizontal carousels. The carousels buffered plastic bottle cap cases for a specific order until the entire order had been received into the carousels. It was then released rapidly to build customer-specific pallets and discharged. Here the robots are seen feeding and pulling from 2 horizontal carousels. Another area of focus in regard to use of robotics in distribution is decreasing the amount of labor in the shipping dock area. In this particular application, the customer had shipping containers that were filled and then moved onto trailers. So we used overhead gantry-style robots and inbound conveyors with extendables that went through the empty containers. We then filled each individual container with cases, placing the container netting up to contain the load while we continued to build additional shipping containers. This is another example of a gantry-style system filling the containers with cases. Another area of focus is the floor loading of trailers, using a robotic attachment to an extendable conveyor. We have a mobile robot that picks up the case from the extendable conveyor and then places it, just like human beings, in a floor-loaded, trailer-type configuration. Here's a little closer view, where you can see the robot picking from the extendable conveyor and placing it into position on the trailer. This could be used for both the shipping operation or for inbound, unloading, receiving operations. Vision systems are critical to the random-type placement of cases. Another area of focus is mobile robotics. Kiva has some very good products. Basically, the robot rotates underneath a portable shelving unit and then takes that particular load to a picking or packing station. This system is very efficient. 2D barcodes are used for mobile robot navigation, and operator stations have extremely high light-directed throughput. As the systems are designed, we typically use simulation at the system level. This was the case for King's Hawaiian out of Los Angeles that had FANUC robots building pallets on the in-feed side and also breaking down the pallets on the discharge side. This application was for a freezer with a multi-deep lane, satellite, or mold-type concept for high-density pallet storage. At the robot level, we designed the end-of-arm tooling and detailed simulation to verify the cycle rates within the cell in which the robot was working. Again, here is another example of detailed robotic simulation to verify the cycle rates within the cell in which the robot is working. Robotic end-of-arm tooling is critical. Our business unit in St. Louis, Bastian Robotics, designs and assembles these custom units. It can be a combination of vacuum or gripping with force feedback. There is a wide variety of end-arm tools. Often, there is a combination. meaning they can pick up both empty pallets and individual products. This video shows the testing done with Saint-Gobain. A group of bottles was a hard product to pick up. A special vacuum was needed to pick up the entire set of bottles simultaneously. We also do compression-type end-of-arm tools. Vision tools continue to advance and provide a lot of flexibility. This particular sensor is from IFM and allows for the analyzation of a pallet to determine the next logical position to place or pick a product. It also reveals if a product is out of position, so this is a huge enabler. The vision systems, with good robotic end-of-arm tooling, allow these operations to take place. Human-machine interfaces are very important in terms of monitoring overall system operation. Here you can see how the various sensors throughout the system are monitored. These are some of our customers in the robotics area. In this project for Berry Plastics, you see a three-dimensional cell being built out. Johnson Controls, who manufacture and distribute batteries, provided a unique application due to battery acids being involved. We utilized plastic conveyors with the hybrids and pure electrical vehicles coming out. Elanco works with animal health protein foods. This palletizing cell both depalletizes and palletizes with no manual intervention. We've also provided several systems for Starbucks. This one, using 2 ABB robots and a high-speed pallet shuttle vehicle, was installed in Reno, Nevada. The Rexam project was yet another distribution robotic system. King's Hawaiian Bakery is a producer of specialty bakery products including breads, rolls, and cakes. We utilized palletizing and depalletizing robots in conjunction with an automated storage and retrieval system to double finished good capacity from 6,500 pounds per hour to 12,000 pounds per hour. This is an example of an automated layer stripper being applied to an interlocks plastic belt, often used in the beverage industry. While we realize this presentation is on robotics and distribution, we want to show a project completed for Hitachi Metal that used 5 synchronous robots in the manufacturing arena, and is a good example of end-of-arm tooling and anodized aluminum slave pallets. And finally, for our client Continental Tire, we provided robots to expedite the tire manufacturing process. The history of Bastian is a 3-generation family business founded in 1952. We have over 250 employees worldwide. Half are engineers of various disciplines. We have over 8,000 customers and are proud of the fact that 80% of our business comes from repeat clients. Our customer base is varied and located throughout the United States, North America, and around the world. Bastian Material Handling's singular goal is to help companies excel in their markets by providing the best material handling system solutions and information technology. We'd be pleased to provide you with more information. Please give us a call or visit our website. On behalf of Bastian Material Handling, thank you.